Have you ever wondered how a massive airliner can land perfectly when the pilots can't see a thing out the window? Well, today we're going to dive into the incredible technology that makes it all possible, the instrument landing system.
I mean, just think about it for a second. You're in a 200-ton machine, descending through a thick layer of clouds. The ground is getting closer and closer, but all you can see out the front is just gray. So how on earth do you find that tiny strip of pavement and touch down safely? It sounds totally impossible, but believe it or not, it happens thousands of times every single day.
This right here is one of the ultimate challenges for any pilot, the low visibility approach. We're talking about landing in thick fog, heavy rain, or dense clouds, where you might not see the runway until the last few seconds of the flight. In a situation like that, precision isn't just a nice-to-have, it's everything.
Okay, so before we jump into the complex world of invisible radio waves, let's start with something much simpler. Let's talk about how pilots land when the weather is perfect. Because to really get how the invisible system works, you've got to understand the visible one first.
So, on a beautiful, clear day, pilots use a clever visual aid called a POPI or VASI system. It's basically just a set of special red and white lights sitting next to the runway, and they give pilots a perfect visual clue about their descent angle.
And the way they work is honestly brilliant. It's all just a simple color code. If you see 2 red lights and 2 white lights, you're on the perfect glide path. If you see all white lights, you're coming in too high. And if you see all red, well, you're getting dangerously low.
Of course, pilots have a classic little rhyme to remember it by, and it's pretty memorable. Red over white, you're all right. Red over red, you're dead. It's this simple visual system that's really the foundation for the electronic one we're about to explore.
And that brings us to the key question, right? This light system is fantastic, but it's completely useless if you can't actually see it. So how do you take this simple, life-saving guidance and make it work when the world outside is just a total whiteout?
The answer is genius. You replace visible light with invisible radio waves. The Instrument Landing System, or ILS, essentially creates an invisible runway right there in the sky, a super precise electronic path that leads the airplane directly to the touchdown point.
So here's the official definition. The ILS is a ground-based system that sends out 2 very specific radio beams. One beam tells the pilot if they are too high or too low, that's your vertical guidance, and the other tells them if they're too far left or right, that's your horizontal guidance. You put them together, and you have a perfect path right to the runway.
Now this is where it all starts to click. Remember how the visual system uses 2 colors, red and white? Well, the ILS does the exact same thing, but with 2 different radio frequencies, 90 Hz and 150 Hz. The plane's antenna can tell which signal is stronger, and that's how it knows if it's above or below the path, just like our eyes see the red and white lights.
So let's just break that down really quick. The ILS is made of 2 main parts. First, you have the glide slope. Think of that as your up and down guidance. Then you have the localizer. That's your left and right guidance. A pilot's job is to follow both of them perfectly, and if they do, they'll be guided with unbelievable precision.
The glide slope antennas are usually sitting right next to the runway. They project 2 overlapping radio signals. The 90 Hz signal is aimed just a little bit high, and the 150 Hz signal is aimed just a little bit low. And right where those 2 signals meet, in the middle, they create that perfect 3-degree descent path that pilots follow all the way down.
The localizer works the exact same way, just turned on its side. Its antennas are at the far end of the runway, and they beam a path straight down the center line. And this path is incredibly precise. Right at the start of the runway, it's only about 700 feet wide, so there is very little room for error.
Okay, so we've got these invisible radio beams cutting through the sky. How does a pilot actually use them? Well, let's jump inside the cockpit and see what the pilot sees.
It all comes down to a display that's surprisingly simple. Those complex radio signals get translated into the movement of 2 little needles, one that moves up and down for the glide slope, and one that moves left and right for the localizer. The pilot's job? Fly the plane in a way that keeps those 2 needles perfectly crossed right in the center.
And the technique is really intuitive. They call it chasing the needle. If the horizontal needle moves up, above the center, it means the ideal path is above you, so you're too low. The pilot has to gently fly up towards the needle to get back on course. It's this constant, delicate dance of tiny adjustments all the way down.
Now, here's a super critical safety detail. Pilots are always trained to intercept that glide slope from below. And why is that?
Well, it's because the radio signals can actually bounce off the ground and create false glide slopes at dangerously steep angles, like 9 or even 12 degrees. Coming in from underneath makes sure you only lock onto the one true, safe 3-degree path. So when you put all of these pieces together, the localizer beam, the glide slope beam, and the pilot's skill in following those needles, you get something truly remarkable, the precision approach.
What this all really means is that the ILS creates a perfect three-dimensional pathway, like a tunnel in the sky. It funnels the aircraft directly and safely right onto the runway, even when the pilot can't see a single thing outside.
And this technology gets even more amazing. As you can see in this table, there are different categories of ILS that allow for landings in worse and worse weather. A standard Cat 1 approach lets you get down to 200 feet above the ground before you have to see the runway, but just follow that table all the way down to Cat 3B.
Yeah, you're reading that right. 50 meters. A Category 3B ILS approach means a specially equipped plane with a specially trained crew can land with as little as 50 meters of visibility. That's less than the wingspan of a 747. It is an absolutely mind-blowing feat of engineering.
But even with all this incredible technology, the human pilot is still in charge. At a specific altitude called the decision height, the pilot has to make the final call. If they look up and see the runway lights, they continue the landing. If they see nothing but fog, they have to hit the power and go around for another try. The technology is an amazing guide, but the pilot is always the commander.
And this kind of brings us to a really interesting final thought. We already have systems that can use the ILS to perform a fully automated landing, a so-called auto-land. So, as we keep moving forward, what becomes the most critical role for that human pilot in the cockpit? Is it their judgment? Is it managing the complex systems? Or is it simply being the ultimate final backup for when the technology, inevitably, has a bad day? Makes you think, doesn't it?